All right, good morning, folks. Day 3. We have what you're looking at right in front of you is the answer to the exit ticket form from yesterday. Most of you were able to navigate it pretty well, actually. I'm actually really proud of you guys for how many of you tackled this topic, because this is, if I'm being honest, one of my least favorite topics to teach because it's so what's the word I'm looking for? It's just very tedious and it's a process, but most of you navigated it pretty smoothly. So just to kind of remind everybody of the whole process of this ambiguous case of law of sines. So we have our given two sides and a non-included angle, all right, so angle side side, okay? In the given situation, we can identify angle B first, which is what you're seeing in the steps here, and I'll let you pause if I'm going too fast here, but ends up being about 50 degrees. So the second we solve for angle B and we actually get a value for it, we know minimally there's one triangle. So what I would then do is at least consider the possibility, let me see if I can get this mouse out of the way, consider the possibility of two triangles. So we know if angle B exists and there's a second triangle, the corresponding angle B would be supplementary. It means they would both add up to 180. So if this being angle B was 50 degrees, then this angle would be 130 degrees in a second triangle. So if you want to treat them at this point forward kind of as two different triangles, even though they have some numbers in common, that's probably a wise choice. So just continue solving for whatever information. If since I asked for part C, side length C, you need angle C, and you get that from subtracting from 180. We now would have A and B, so you can subtract to get the third angle. And then you can set up another law of sines to get length C. So the first triangle is going to be 20.8 feet. The second triangle, we have given angle A, we just got angle B, so again we can subtract and get angle C in the second triangle, which is 15 degrees. So doing a law of sines leads us to a second side length C, 5.4. Okay? Just a quick check here to make sense of our answers. Both of this is all accurate, but just keep in mind the longest side of the triangle will always be opposite the largest angle of your triangle. So here in my second triangle, C, angle C, was 15 degrees. So that's the smallest one. So it kind of makes sense that side length C is such a small number. Little things like this from geometry you might remember are useful to just kind of make sense of your answers. They're not a perfect system, but they're just ways to help reason and make sense. So, on to the new notes. This is actually, I only have one piece of paper for you guys. One example, and we're going to close out the section with this. So, with sine, we have our law of sines that helps us kind of find missing pieces of information. But sine, the last thing we're going to do with it is help find area of a triangle. And I use this word oblique triangle. And that's basically saying that I have an oblique triangle, meaning it's not a right triangle. It can be any type of triangle. It can be a right triangle, but it doesn't have to be. And the way this formula works is, I know you're used to, if it's a right triangle, 1/2 base times height. If you don't know the base or the height, this is basically that equivalent formula when you're solving for them. So 1/2, and then one of the side lengths would be your base, and then the other side length times sine of an angle would be your height. All three of these are equivalent. It's just a matter of what pieces of information you have. So you definitely want to get this down in your notes. Again, we're going to add this to our formula sheet on the next quiz or test that we take. This would be provided for you, but you want to make sure you have this for reference sake. And the thing to note about this is the lowercase letters, those are side lengths. So we have side B, side C, angle A. Side C, angle B, side A, side B, angle C. Notice in all three of these, though, you have an A, a B, and a C in some combo. So we have now, oh, one last thing before I move on. You should note that if I have triangle ABC, all of these use two sides and the central angle. Meaning, when I say central angle, if I have side C given and side B given, angle A, the central angle would be the angle in between those two side lengths. So that would be the side angle side pieces of information you need for this. Okay, I'm just going to adjust. This seems like a really dark. All right, hopefully this shows up a little bit better now. I don't know if that's too bright, but it seems dark. So let's finish up this example. We have an area of a triangle that has side lengths 24 and 10. The central angle, meaning the one in between those two side lengths, is 62 degrees. So I'm just going to draw a quick reference triangle, not to scale, but we have a 62 degree angle there, side lengths of 10 and 24. All right. Notice we would not be able to solve the rest of this triangle using law of sines, but we can at least get the area of this triangle. And then area is 1/2 10 times 24 times sine 62 degrees, and I put this on my calculator before. I'm going to round it a little bit to about 106 square meters, or meters squared. Okay? That's it. That's the only example today. This is a pretty short video for you guys. I'm going to list in the Google form a couple problems referencing textbook questions, so make sure you're able to log in your textbook and make sure you fill out the Google form today. Hopefully everyone's staying safe. Hopefully everyone's washing their hands. Enjoy.